Okay guys, so in this video I'd like to talk a little bit about the specifics of getting your notebook ready for week 1. Well, it's actually week 2, isn't it? For lab 1. So the lab that we're going to be doing is this use of volumetric glassware, the floating egg problem. And in this lab, what we're going to be doing is we're going to be making some salty water that is just able to float an egg. And when an egg is just able to float in a solution, what that means is that the object that is floating has the same density as the solution. So what we'll then do is we're going to take 25 ml samples of that solution. We know the volume, 25 mils, weigh them, and we'll calculate the density of that solution. Because the density of the solution equals the density of the egg, we're going to indirectly get the density of the egg. So you want to read through the description of the experiment. There's lots of hyperlinks in here that will take you to information about key terms, key pieces of equipment, key chemicals, and so forth. And at the very end of the description of the experiment, there are some strategic hints, and in particular there are a series of videos that show you how to operate some of the glassware that we're going to be using. I would encourage you to read through this fairly closely. Okay, it's going to give you a good overview of what's going to be happening in the lab, and you'll be able to get going a bit quicker than if you haven't done that. Okay, so there are some things that you need to do before you get to the lab, and one of them is to write a purpose. And so according to the instructions that you've been given, it says the purpose should be a summary of the scientific work you will complete, not the learning outcomes. Typically, this is not found in the manual completed before class begins. So this was taken from a different quarter, and we don't have a manual, we just have an online assignment. But the rest of the text is correct. It is a summary of the scientific work you will complete. Typically, this is not found in the description of the experiment. Complete this before class begins. So I put 3 different purposes here from different quarters, and let's see what we've got. So a summary of the scientific work, not the learning outcomes. So basically what they're going to be doing in the lab. So it says here, purpose, to determine the density of a single egg. Okay, and then use class data to compare the density of eggs with different ages and see how egg age and egg density are related. And that one is pretty good. If you read the introductory material and the report, you'll realize that there are 3 things that we do. One is we determine the density of an egg. And they covered that in the purpose there pretty good. The next one is that we compare class data to see how age and egg density are related. Now you have to read in the report to kind of recognize that that's part of what we do. And then finally, the other thing that we do is we compare the precision, not the accuracy, but the precision of different types of glassware. So there's really 3 things that we do, that the 3 bits of scientific work that we're going to be doing. This guy got 2 out of 3, so I gave him 4 points for his purpose, because it's kind of tricky. Okay, so this one, it says, in this experiment we will be measuring the density of one egg from one of 2 groups A or B. This is true. To determine the age difference between the sets, and that is nonsense. We will not be determining anything like that. So they got basically 1 out of 3 bits correct, but they also just totally misinterpreted what we're doing. So they got less than 4 points for their purpose. So don't make stuff up, right? And that last sentence there is completely erroneous in that case. Okay, here's another one. It says to find the density of an egg. That is true. By finding its mass, then dividing it by the volume, and again, that is just made up. That is not at all how we're going to determine the density of this egg. How we're going to determine the density of the egg is by floating it in a salty water solution and then determining the density of the salt water solution. So this was nonsense. We will compare with two sets of eggs to see which worked better, an older egg or a newer egg. And again, that's kind of nonsense. What do we mean by worked better? All right, so again, I mean, that's unrelated. Nothing is doing any work here. It's just nonsense. So that guy got less than 4 points, right? He got 1 out of 3 bits correct, and then he got 2 things that he kind of just made up. So, so be aware, don't include things that are not, that you're just kind of inventing. I will read these and grade them accordingly, right? And I know that there are 3 things that we're going to be doing. If you mention a couple of them and you don't make stuff up, you're going to get 4 points. All right, let's have a look at procedure. So the procedure is a description of the procedure you will follow in sufficient detail another student could replicate your work without referring to another source of information, and again completed before class begins. So here's a first one. It says, so I think this sufficient detail is important. We need the identity of things, and we need the amount of stuff, or otherwise there isn't enough detail, right? So that's important. Procedure. A burette. Bring 120 milliliters of salt, 1000 milliliters of solution. And my question is, what kind of solution? We don't actually do that. That should have been water. So he mislabeled that. And 1 egg to the table. So it's not awful. Add 20 ml in increment till it floats. The problem here is 20 mils of what? Add 20 ml. Make sure you have your burette, volumetric pipette. That you don't need to do stuff like put your safety goggles on, bring equipment to the table. You don't need to do that. It's kind of like saying, if you're giving someone directions to drive somewhere, you wouldn't say, get your car keys, sit in open door, sit in car. That's not how we do it, right? Pour solution into Erlenmeyer flask and then weigh it. Well, how much? And actually, this has actually got nothing to do with it. Determine the mass of the solution of the volumetric. This doesn't even make any sense. So at this point, this guy's heading fairly close to getting 0 for this, because there's just, I don't even know what this is. Right? Now, this next person here, they kind of have a much longer procedure. Note here that they've completely obliterated this text. We never do that in the chemistry lab. So if you have a number 3.14 and then you realize that it should have been 3.41, what we do when we make a correction is we just draw a line through it. So it is still legible, but it's clearly indicated that it's an error. And it's for that professional practice piece that we do this. We want people to be able to see that our errors are legitimate. We just made a minor slip. We're not hiding anything, right? So we never obliterate something like that. And then the other thing we don't do is we don't use whiteout. Okay, we never use whiteout in the lab notebook. And you can see this person has used the sort of scribbling out protocol all the way through here. We don't want to do that. Okay, so I'll just read a little bit of this. It says, obtain from the available materials an egg, 120 ml of salt within a labeled beaker and distilled water. Bring the materials back to your bench. Note the code of the egg. Utilizing the distilled water, create 1000 milliliters of the solution. I don't know what the solution is. Begin adding 20 ml increments of salt until the top of the egg just touches the top of the solution. So, I mean, I think it's like, I won't read it all, but it goes on for several pages, and it's too much. If you're writing 2 pages, you've probably written too much, and it's not terrible. It's better than the first one. I would give this 4 points, but I think the person probably exhausted by the time they got this done. This is my favorite one out of the 3 that I chose. It says, about 1 liter of a saltwater solution just able to float an egg will be prepared. Okay, add salt to water to about 1 liter of water until an egg just floats. Perfect. 25 ml samples will be taken with a burette, a pipette, and a volumetric flask. Okay, and then weighed. Perfect. We will then take 3 samples with each device for a total of 9 samples. So you're going to do 3 with that, 3 with that, 3 with that, and that'll give you 9. Okay, from this data, the density of the egg will be calculated by comparison of class data for eggs with different ages. We will then determine how egg age and egg density are related. And so I think that this is perfect. It's not too long. You know, anybody could copy this. I think that one is by far the best one. All right, let's have a look at an example or some examples of the data section in the lab notebook. Just notice the purpose and procedure done before arriving at class. Maybe give yourself about an hour to do that. Hopefully it takes you a lot less than that. And then consider sending me a copy for review before you come into lab, and I can give you some pointers. All right, let's look at the data section. Okay, so I'm going to look at the terrible one first. This is, I mean, I can't even read it. You know, it's just, I have no hope. This would be pretty close to like a 1 out of 5 or a 0 out of 5. I mean, they did something, but I can't tell what it is because partly it's scanned so poorly. And then they've got sections A, B, and C over here. They've got, it's not too bad, but it's just kind of poorly scanned. They did a pretty good job of making their corrections. They didn't obliterate stuff. Okay. Now, here's what you don't want to be doing. This person kind of came in and they weren't that well prepared, and they realized that the tables that they'd made were not actually what they wanted. And so they ended up just like giving up, right? And they had to scratch everything out. The big cross through is good, but this kind of like obliterating stuff is not really cool. We don't want that going on. And then even when they did rewrite it, they were very concerned about not having any corrections. And you can see in multiple cases, they've used correction fluid. And that's how you end up with crazy, folks saying that your results are invalid, or, you have to go back and do it all again just because someone in your lab used correction fluid and it's not it's not considered good practice. So keep that in mind. Again, they did a lot of work here because they did everything twice. If you can avoid doing more than what's needed, that's going to really help. Here we go. This is my buddy Eric. He did this. It looks good. His tables are nicely ruled up. That helps him keep everything straight. When he did make some errors, he corrected them appropriately. It's just 1 and a bit pages. It's nothing too excessive. I can see everything really, really, really clearly. He wanted it to be known that he was the scientist that did the work here. That's fine. He previously worked in the lab. He knew to do that. I like how he's put the units in the table heading, and then if he forgets to write the units anywhere else, it doesn't matter. Whereas if I look down here, in particular, there's no units in the table heading. And so then you've got to remember to write them in every time, or otherwise, you're going to be like, people are going to be like, so what were the units on that number? All right. And so that can be an issue. So I like that idea. That's a really good practice to do that. So again, it's just, 1 page, it's neatly laid out. neatly laid out is not the same as having immaculate handwriting. I have pretty awful handwriting. If you've got bad handwriting, a good way around that to make things clear is just to write big. A composition book costs like $2 and has way more pages in it than what you're going to need for the whole year of chemistry. So that first example there by Eric, that looks really great. These other two, the second one's not too bad, but they definitely made a lot of work out of it, more than what was needed. And then the third one is, that's pushing getting a 0. Okay, so for your conclusion, you have to summarize the key scientific results. And like I said, it reflects on the purpose. So the things that you say you're going to do in your purpose, you should address in your conclusion. All right, doesn't include a discussion of the results. So you don't have to say that, this was you don't have to give reasons for things or anything like that. It doesn't involve a discussion of the learning objectives. So you don't have to say I learned a lot, or this was an experiment where I learned how to use particular glassware. It's not really like that. It's more of the type of conclusion that you would write if you were working in a professional lab. You do this after the lab, and I strongly recommend doing it after you finalize the report, because you may not even know what the key results are until you've answered all those questions. But remember what we said, the key results in this case were you're going to figure out the density of one egg. You're going to look at the precision of 3 different pieces of glassware. And then finally, you're going to be looking at how density and age are related. And you're going to do that by looking at class data. So some people will have eggs that are 2 weeks older than other eggs. And you can see, does the density become more or less with time? All right, so let's have a look at this one. The eggs in group A were less dense at, and then they're given number, but they go no units. The units there should be grams per mil. And group B was more dense at, and again, I don't really like this. The burette proved to be the best tool. What do you mean by best? Do you mean the most accurate? Or do you mean the most precise? And most reliable. Does reliable mean it didn't break? I don't know. Tool. And most reliable tool is the volumetric flask. Whereas the volumetric flask was the least reliable tool. Again, what do you mean by reliability? Thus, this experiment has proven that old egg float and new egg sink. So I think they're saying that old eggs, they float, so they are less dense, and newer eggs are more dense. I'm having to do an autopsy on the guy's paragraph to understand what he's meaning, and it's quite confused. The language is, they're not using the technical language properly. Units are missing. This is definitely not a 5 out of 5 conclusion. The first thing I see when I read this is, oh my gosh, it's a lot. We only had 3 things. We needed to comment on the precision of 3 pieces of glassware, how egg age and density are related to one another, and the density of the one particular egg that we were looking at. So what I've got, what I'm seeing here is an awful lot. So I'm not so impressed with this. So let's look on just because it's a lot of work for the person. I would probably give them 4 marks, but they sure did do a lot of work. Now, let's have a look at this one. On completion of our experiment, Jaya and I found that through directly measuring the density of our saltwater solution, we indirectly measured the density of our egg. Our results averaged over 3 glassware tools, burette, flask, and pipette came to be 1.109 grams per mil for the density of our egg, egg B. When evaluating class data and averages, we were able to conclude that egg age does play a small role in the density of an egg. The older the egg, the less dense it will be. And now I think that that's brilliant. The only thing you didn't comment on was the precision of the 3 different types of glassware, which were the burette, the flask, and the pipette. And, I don't feel too bad about that. He got 2 out of 3. He didn't include a bunch of stuff that wasn't unnecessary. I think that that's a pretty good conclusion. I would give that 4 marks. All right, guys, so I hope that that kind of helps you get started and gives you some idea as to what is required for your lab notebook. And in particular, remember that you need to get the purpose and the procedure done before you arrive at the lab, and you are welcome to send me a draft if that helps you out. Okay, good luck with everything, and this will be getting posted to Canvas, soon. Okay, bye.